our first lab of the year. It's a simple one. We're just going to find the velocity of what we call a low friction car. It's going to be moving on a horizontal track so that we ensure a constant velocity. These horizontal cars that we're going to use are going to look like this. You guys have never used these before. These little plastic, almost toy-like cars are pretty low friction. If you give the wheel a spin, it keeps spinning for a long time. Okay, you pay a little bit more for carts that spin for a long time like this, as opposed to a toy car that you buy at Toys R Us, right? These also have a number of electronic sensors inside them that will wirelessly transmit data real time to our phones. That's how we're going to collect data with these this year, as opposed to standing on the side of the hallway with a stopwatch as a car goes past you and stopping the stopwatch when the car goes past you. We're going to collect that data electronically, and we're going to send it wirelessly real time directly to your phone. Then we'll send it to a Chromebook, and then we'll do our analysis on the Chromebook. So we're going to find the velocity of one of these toy cars or one of these low friction cars on a horizontal track. A problem is the purpose of a lab. This is always what we're trying to accomplish. In this case, find the velocity of the low friction car. But that problem always needs to be phrased in the form of a question. I'm telling you exactly what that question is this time. I want to find the velocity of a car. Okay, the problem is, what is the velocity of a low friction car moving on a horizontal track? Next time, I might just say, hey, we're trying to find the acceleration of a car. You will rephrase that in the form of a question. Make sure you put a question mark at the end of it. Questions need question marks. The next thing you're going to do for this lab will be your materials. Sometimes we'll need to do a procedure. Sometimes we'll need to do variables. For this one, we don't. For this one, the next entry that we need to do is your materials, your apparatus. It lists what you're using. Now, I've got a picture of our apparatus here. The only reason I've done that is just as a little maybe note to self. When you're doing a lab, not a bad idea. You don't have to do this. Not a bad idea to take a photograph of what of your apparatus, and that way you're not going to forget materials later on. Does that make sense? You got to write this up 2 days later. Oh, what did we use? What are all the materials we use? If I've got a picture of that, then I'm not going to forget that. We still need to list those materials with words. Now, this blue cart that you see here is what I was just showing you a minute ago. We're going to say this is our low friction cart. So you're going to list a low friction cart. What else are we going to use? Well, that low friction cart has to be on something. We don't want it to be on the floor because there's dust on the floor, and then the dust gets in the bearings of the low friction cart, and then it becomes just a cart, not a low friction cart. We don't want that, so we're going to put it on a track. Some of the tracks are wooden tracks, some of them are metal. It doesn't matter which ones you guys use. Bottom line is, everybody's going to need a track. And I mentioned to you a minute ago that you're going to wirelessly transmit data to your phone, or at least to one person in your group's phone. We don't have to have everybody's phones running here. We just have one person per group running an app on the phone. So we're going to say your phone is the other piece of apparatus that you're going to use. There's only 3 for this one. Sometimes it'll be 3, sometimes it'll be 5, sometimes it'll be 6. It all depends upon what you're doing. Now, you are going to need an app on the phone, but we don't need that kind of detail under the apparatus. You don't need to tell me what app you're using. You need to tell me the physical materials you're using. If you happen to use a pencil to make a note, you don't need to tell me you're using a pencil. If you made a mistake with a note and you erased it, you don't need to tell me you're using an eraser. These are the main pieces of equipment that we're using. The 3 critical things that we're using with this lab. So these are the 3 critical things that we're writing down. Now, I'll explain the procedure in a little bit here. We're just giving you an overview right now. The next thing we're going to need to include with this is your data and observations. This is what your data is actually going to look like, but that's not what you're going to record in your actual lab write-up. In your actual lab write-up, it'll look more like this. We're only going to have 2 columns, time and position. Now, this is a data table, and all tables, data tables, analysis tables, and whatever, should be titled. The first one will be titled table 1. Table 1 colon, and then we would say position of car, if I could spell position. The problem is talking and writing at the same time. Position of car, we'll say as a function of time. Position of the car as a function of time, or something that's pretty much like that. Position, the word position should come first, time should come second. Position versus time, position is a function of time, something like that. And our data table should look pretty much like this. All of these columns scale down to these 2 columns. I'll show you later on how to do that. Don't panic about knowing how to do that right now. If you do, that's awesome. If you don't, that's awesome too, because I'll explain it to you. Once we have our data, we're going to go to our analysis. Our analysis is going to involve a graph. Now, I'll show you later on how to plot the graph as well. This is the overview, remember, okay? The details are going to come later on, step by step, as we get there. That graph should be a position versus time graph. One thing that you need to add that Google Sheets will not do for you, to the end of your title where it says position versus time, I want you to put in brackets your initials, not my initials. My initials are BD, that's what I would put. Your initials are whatever they are. You're going to put your initials in brackets. Why do you think I'm doing it? Why do you think you're putting your initials after it? It's so easy to copy and paste a graph, right? Or to screenshot a graph and then paste it into your lab, right? Well, if you have to put your initials, then you have to plot the graph. Does that make sense? Don't forget your initials. That's a small thing, but if you don't put your initials, that's one little detail that's going to cause you to lose a point. You'll remember that if you go through your rubric, because it tells you right there, initials on graph, 1 point. Now, you can see this graph, position versus time, everything's there. There's a line there. I'll show you how to plot that. There's an equation up here. I'll show you how to put that equation in there as well. Many of you have plotted graphs on Google Sheets already. That's fantastic. If you haven't, don't worry about it. I'll walk you through that process of doing it the first time, or reminding you of how to do it if you have done this before. Once I've got my graph plotted, I'm going to answer some analysis questions. You don't need to copy down these analysis questions. They're already typed out for you in your template. The answers aren't there. They will be there because I told you I'm going to walk you through every step along the way, including the answers to these questions. Sometimes we will see analysis questions, sometimes we won't. If we do, they'll be typed out for you already in the template. You just answer those questions in complete sentences. Then we're going to have our conclusion. The conclusion always relates back to, well, if we have a hypothesis, it relates back to the hypothesis. In this one, we don't have a hypothesis, so it relates directly back to the problem. The problem was, what is the velocity of this car? So the conclusion is, the velocity of this car is, and then you're going to fill in the number. I'll show you how to get that number as we walk through this. You're going to fill in the answer to the question, right? What's the velocity of the car? Okay, tell me what the velocity of the car is. And then how do you know that this is the velocity of the car? Well, I'll walk you through that as well once we get to that stage. Finally, the last thing you're going to do for this is what we call sources of error. You're going to identify non-human sources of, well, for lack of a better term, error. Things that could have been better for this. Things that could have led to data or analysis, sorry, not analysis, but things that could have led to data that didn't work out quite right. Something's off. This is why perhaps something could be off. We're not going to use human error here. This is not like, I made a mistake doing this. Well, then fix it if you made a mistake. Don't write that down as a source of error. Maybe it's an issue with the apparatus. Maybe next time we could do this with the apparatus to make it better. Maybe it's an issue with the procedure. Maybe we could do this next time with the procedure to make it better. But listen, when we get to that point, after you've collected data, I'll walk you through that too, for this one. Hopefully I'll have walked you through it enough that you'll get 100% on this. And then next time, when you actually go to write up your lab yourself, you'll remember all these little details that we talked about, and you'll nail that one too, except you nail that one by yourself as opposed to me doing it for you. This